All right, so on a proof like this, you got two columns. The left side is the statement, whatever you're saying, and the reason, the rule is on the right. They're going to give you something to start with. So they gave me that AD is equal to DC. So I'm going to mark that on the paper. Whoa. AD is equal to DC. All right. Can anybody tell me something else that would work on this? How do we know? Y'all are missing something that we normally talk about. What do we normally, if I was trying to say side angle side or angle side angle, what would I do first on this problem right here? I'm going to do the thing with the X in the middle. All right. What that's called, well, I'm going to say that dB is equal to dB, and the rule is reflexive. It's the same in both of them. All right. Can somebody make the triangles be equal right now? You can't?
Oh yeah, you can. You can be on AB, you mark two, and
Can you?
CB.
Why?
Because it's the same. It's got the vertical thing with the arm right there. Going to me like when it got the X in the middle, it's the same.
Almost. I've got to say that the triangles are the same before I can do the sides are the same on that one. All right, but I can say right now, I'm going to do this. I'm going to say that angle ADB is equal to angle AD, or excuse me, CDB. And if I have one right angle, I really have two. Now look up there. Can I say that those triangles are the same?
Yeah, no. Yes, yeah.
What rule?
The reflection.
Look up there. Forget about all this junk.
Side angle side.
Side angle side.
Side angle side.
Everybody see it?
Yeah.
Side angle side. Side angle side. So that's what it's going to be on the EOCT, except they're going to do like this right here. They're going to have everything done, and you're going to have to fill in one part. Well, look at what this last part is. What it's asking me to prove. That two triangles are equal. Well, how can triangles be equal? What's some rules?
Side.
Side angle, all that junk. So if it's like this and it's asking you to prove a triangle is the same, it's going to be one of those answers.
What if it ain't?
It's got to be. I mean, that's your only choices. Now, since this is a right angle in here, I could also say that is leg, and that would work. All right? So you've got to look at what you got. If it's this right here, it's going to be one of those side angle side. You just got to look and see what stuff they've got written up here. Does that make sense? You see what they've got in here, mark it on the figure, and say, well, then what rule is going to work for what they said? All right? All right. We'll just do this one. All right, it tells me that AB bisects ADC. What does bisect mean?
Cuts in half.
Cuts in half. So it's telling me that AB, this part right here, cuts that angle in half. What does that mean about those two angles at the top?
They're the same.
They're the same. So I'm going to mark them as being the same. So angle ADB is equal to angle CDB. And that's because it was bisected. All right. It also tells me that AD is equal to DC. So what am I going to do with that? Mark those two sides. All right, so what else can I say is the same? That if I gave you that, you would look at it and say that's got to be the same. The X in the middle. So then I'm going to say dB is equal to dB. And what rule did I say a minute ago? No. If it's the same thing in both of them, it's reflexive because It's reflecting basically. So look at what I've got over there. Is that enough to say that those angles or triangles are the same?
Yeah.
So I would say in this case, triangle ADB is equal to triangle CDB by side angle side. But is that what it's asking me to prove down there?
No.
No, it's asking me to prove that a piece is equal to another piece.
A, B,
Here's where I'm going to tell you how to cheat. If it ever does that right there, and you got to prove a triangle, or it's got all of this stuff up here, and it shows that a triangle is congruent, and then the last step is one of the pieces, the answer is always going to be this right here.
C, B, C.
What that stands for is corresponding parts of congruent triangles are congruent. In other words, the pieces are the same. So if you ever have a triangle congruent for the next to last step, and then the last step is a side or an angle or whatever, that's always going to be your answer. All right? Now, they may do something like this. You know, and ask what that step is. Well, if it's the same thing over again, what is it? It's reflection. I know we didn't do we didn't do any proofs, but there are some shortcuts to some of these things. That may be all. I want to do this one. All right, if I'm looking here, it tells me some lines are parallel. Which things can I say are equal when I know parallel lines?
2 and 3 and 4 and 5.
Nope.
B, C.
2 matches what?
3.
Nope.
1.
5.
Nope. Nope.
4.
2 matches 4. Why? What kind of angles are those?
All I know we're doing that like X to
I thought you said it. Angle 2 equals angle 4, and angle 3 equals angle 5 because they are alternate interior.
That's what I was saying.
That ain't what you said.
I know I said I know we're doing that like alternate interior.
All right, so I've got those 2 equal, and then those 2 equal. I'm trying to show that 1 plus 2 plus 3 is equal to 180. What do I know about this right here? What does angle 4 plus angle 1 plus angle 5 have to equal?
180.
Why?
Because it's a line.
Because it makes a line. Now, look at what I said. 2 is equal to 4. So if I take that 4 out, I can put in a 2, right? Because they're the same. And if I say 3 is equal to 5, I can take the 5 out and put in a 3. And all I'm doing is substituting on that. Is that what I'm supposed to say?
Yes.
1 plus 2 plus 3 is 180? So we would be done. And they may do something where this, you know, they'll leave the last step off, or they may leave this step off with the alternate interior. You've got to be able to pick out the part that they're talking about and see what rule works for that. We should already kind of know this. If I want to classify a triangle by its sides, or excuse me, well, angles and sides. Well, what are we doing first here? Angles. Acute, all 3 are small, less than what?
90.
Less than 90. Obtuse has 1 that is bigger than 90, but the other 2 are still less than 90. Right triangle has 1. Equal angular. What does the equal part mean?
They're all the same.
Equal. They're all the same. They're all 60. If I want to do it by sides, scalene, no sides the same. Isosceles, 2 sides the same. Equilateral obviously means all sides are equal or the same. And then this last part right here, centers of triangles. All you've got to do is memorize these things. A centroid is the intersection of the medians. Orthocenter, intersection of the altitudes. Incenter is the intersection of the angle bisectors. And circumcenter is of the perpendicular bisectors. That's just something you've got to memorize. We'll talk about it again right before the EOCT. All right, are we good there?
When is it?
All right,
We won't catch it.
the special right triangles, you got two types, 45, 45, 90, 30, 60, 90. I hope we remember those. The deal on the 45s, what happens with the two legs? They're the same. And you get the hypotenuse by taking those legs and multiply by root 2. 45, 45. If the angles are the same, the sides are the same. Very simple. So if I were to do this first one right here, this would be an 8, and this would be
Square. Square.
8 root 2. All right?
Wait, would we put it as 8 root 2 or just like put it
You put it 8
exactly?
root 2. That's the way they're going to have the answer. If they give you the hypotenuse with a root 2 on it, well then what are the two legs going to be?
5.
They're going to take that root off. It'll just be 5 and 5. All right? If it's something like this where you've got a root but it's on the leg, well the legs are still going to be, the legs have to match. And then I would get the hypotenuse by saying the leg times root 2. What's root 2 times root 2?
2.
It's just 2. 6 times 2 is 12. All right, those are easy now. We should get those. What if it gives me something like this? 7 root 10 for the hypotenuse.
So it'd be 75.
I'm going to divide by root 2 and get 7 root 5, and that's going to go for both of those. If it gives me a whole number, do we remember what happened when I did that? 10 divided by root 2?
It's 10 root 2.
You had to multiply top and bottom by root 2. You get 10 root 2 over 2, which is 5 root 2. All right. Now, what happened? Do we remember what happened if this was an odd number right here?
No.
What's the answer going to be? If I do this, multiply by root 2 and root 2, I get 11 root 2 over 2. It's going to be a fraction. So then that would be my answer there and there.
So you could put a decimal in there?
You could, they're going to have it as a fraction. Now, you could do it as 5.5 root 2, but they're going to have that. All right, 30, 60, 90. The short side is always across from the 30. Small angle, small side. The long side is always across from the 60. And the hypotenuse, of course, is always across from the right. The rule says the 30 is your x. How do I find the long side if I know the short side? Multiply by root 3. How do I find the hypotenuse if I've got the short side? Multiply by 2. So what I really want is the short side. Because if it gives me the short side, okay, here's 5. I know this is 5 root 3 for the long and 10 for the hypotenuse. If it gives me some crazy something like that, I'm still going to multiply by root 3 here. And I'm still going to multiply by 2 here. Remember, you can only multiply a regular number to a regular number and a square root times another square root. What if it gives me the hypotenuse? What do I need to do?
Divide.
Divide by 2 to find the short side first, and then multiply that short side by root 3. If it gives you the long side, what do?
You take the root 3 off.
Divide by root 3. So 6 root 3 divided by root 3 is 6. That's my short side. Short side times 2 will be 12 for the hypotenuse. All right? And again, there's the rules. If it gives me the short side, all I'm doing is multiplying. If it gives you short side, you multiply. If it gives you anything else, your first step has to be divide. So if it gives me hypotenuse, I divide by 2. If it gives me long side, I divide by root 3. What side do I want to find first if I don't give it to me?
Short side.
If I don't have the short side, that's the one I gotta find. So I find that, and then I use that one to find what's missing. All right, let's get to, this stuff right here. Sine, cosine, and tangent. There's gonna be a ton of this stuff on there if it's like what it's been in the past. Let me go ahead and put tangent on here too. What's tangent?
None of barely touched the Oh.
Opposite over adjacent for the trig ratios.
No, I agree.
Better learn it now. All right. It is always based off of the angle they tell you to work with. We will not use the right angle on this stuff. It's always one of the small ones. So if I want to do sine of A, I go to A. Which side is opposite from A? There's my opposite. What is this one?
Adjacent.
That's my adjacent. And this is always what right here?
Hypotenuse.
All right? That's if I'm dealing with A. If I'm dealing with B, that means I'm down here. So what is that side right there?
Opposite.
Now there's my opposite. And here's my adjacent. Which one never changes though?
Hypotenuse.
The hypotenuse will never change. All right? So when I'm doing sine, cosine, and tangent, I go to the angle they talk about. Across the triangle is opposite. Right next to it is adjacent, and we should never miss hypotenuse. All right? So if I'm looking at this one right here, give me the fraction that works for sine of B.
15 over 21.
It's 15 over 21, which is 5 over 7. I go to B, opposite for sine, hypotenuse is on the bottom. Remember, for sine and cosine, what's always on the bottom?
Hypotenuse.
Hypotenuse. If I do cosine here,
10, 21.
cosine of B means I'm adjacent to it, right next to it. That doesn't simplify. Now when I go to C, now I'm down here. So which one is opposite from C?
10.
10 over 21.
And then cosine of C would be the 15. What do we notice about these answers?
They're the same.
The sine of one and the cosine of the other one are the same. What if I wanted to do tangent down here? Tangent of B.
10 over 15. No, 15 over
15 over
15 over 10. And then what about tangent of C?
10 over 15.
Just 10 over 15, you flip it. So for tangent, they're going to be the same numbers, you just flip it. We've got to be able to do that right there. There's a bunch of questions about sine, cosine, and tangent. All right, if I wanted to set up this equation right here, a lot of times, all they're going to ask you to do is set it up, not solve it. Which equation would work for this problem? So all you got to do is figure out, is that sine, cosine, or tangent?
this side.
What side is that?
Opposite.
Opposite. What side is this?
Hypotenuse.
So opposite and hypotenuse has to be
6.
sine. So I would say sine of the angle, because angle always goes with sine or cosine or tangent, equals the opposite over the hypotenuse. Remember, if this sine, cosine, hypotenuse is on the bottom. What if I did, let me change one of these right here. All right, what would that be right there?
Tangent.
Opposite and adjacent. So that's going to be tangent. They're going to give you, on the formula sheet, it's going to have sine, cosine, and tangent. Opposite over hypotenuse and all that stuff. So we should not have trouble setting these up because it's going to give you sine, cosine, and tangent. We've already talked about tangent. What about this right here? Number 1. If I wanted to solve for x, I got to base it off of that 24 that they give me. And I've got to use the 10 because that's one of the numbers. So what would that be? What side is the 10?
Side.
What side is the 10? Side, that one is opposite. Then x is what?
Adjacent.
What's opposite and adjacent? Tangent. So I would say tangent of 24 equals 10 over x, and then I would solve that. All right, how would I solve for a y?
You would put 20.
I'm using the 10 still, which is opposite. Y is
Adjacent.
no
Hypotenuse.
hypotenuse, so that would have to be
Sine.
sine. Sine of 24 would be 10 over y. And then you would solve it from there. All right, on the solving part, how do I solve it if the x is in the bottom? Do we remember?
Divide.
You divide. I would do 10 divided by sine, or tangent 24. If the number's in the bottom, what do I do? Let's find one with the number in the bottom. Look at this second one. Sine of 58 will be x over 19. How would I solve that one?
Multiply.
You just cross multiply. If the number's in the bottom, you multiply. If the variable's in the bottom, you divide. But again, a lot of times, all they're going to ask you for is that right there. What equation would work to solve it? Not even solving it out. So we should get those. How would I solve something like this? It says tangent of A is 3/4. Now I need to find cosine and sine. What do I need to do first? Draw a triangle every time. I'm going to just say there's my A, there's B, there's C. It says tangent of A is 3/4. What is the rule for tangent?
Opposite.
Opposite over adjacent.
So that means the opposite side is
Three.
3. The adjacent side is 4. And then how would I solve for that missing side right there?
The cross.
It'll be 5.
Oh, you do the 3, 4, 5.
You should recognize it as a 3, 4, 5. If you don't recognize it, how do you solve it?
The
Do Pythagorean theorem. A squared plus B squared equals C squared. So I would solve it and say, okay, well that's going to be 5. Well, what is cosine of A then?
4 over 5.
Adjacent over hypotenuse, 4 over 5. What is sine of A?
3 over 5.
3 over 5. So that's all you'd have to do. All right? So we should be able to work with it on stuff like that. All right, this part right here, we've got to get these because they normally have at least 5 or 6 of this type stuff. Angle of elevation. Elevate means what? Go up.
Yeah.
So I start at the bottom and I go up. There's angle of elevation. It's always in this bottom right corner. Angle of depression. If you depress something, that makes it go down. So you start here and you go down. The problem is that is not inside the triangle, so therefore we can't use it. But it winds up being right here because of alternate interior. So angle of elevation and angle of depression both wind up in that bottom corner. That's the part. This is the one at the bottom that messes people up. They say depression and they want to put it in the top corner. That's not where it goes. Angle of elevation and depression both wind up in the bottom right corner of the triangle. So if it tells me, oh, wait a minute. If we're trying to solve for an angle and it gives me the sine of theta, remember the theta symbol, I hope. All you got to do is inverse second sine. We remember that? I hope. So you do second sine, type in the fraction, and then it would give you the angle. All right? So if I'm looking at this, man is looking at the top of a tree with a 33-degree angle of elevation. Where does that 33 go?
In the bottom.
Bottom right corner. He knows it is 57 feet from where he is to the base of the tree. Base is
The bottom.
the bottom. How tall is the tree? All right, so there's my setup. Most of the time, they're going to give you the triangle already filled in for you. All you're going to do is either get the equation or get the answer. And most of the time, not both. So the equation here,
It'll be
tangent of 33 equals,
x over 57.
and then you would cross multiply because the number is in the bottom, and you would get your answer. All right? Now look at this one. It says a 25-foot ladder leans against the building and makes a 42-degree angle with the building. So where does that go?
The 25 goes at the hypotenuse and the 42 goes at the top.
How far is the ladder from the base of the building? Then that would be down there. What equation would work for this?
Maybe
Should be sine 42 x over 25, numbers on the bottom, I multiply. All right, an observer is in the tower and sees his friend. The angle of depression is 29. Where does that 29 go?
Bottom right.
It starts right there, but we're going to put it in the triangle down there. So angle of elevation, angle of depression, both go in that bottom corner. How far is it from the observer to his friend if the friend is 185 feet away from the base? Base means bottom. We just said the observer was up here and the friend was down here. How far is it between them? What would my equation be for that?
Cosine.
Cosine 29,
80,
185 over x. How do I solve that again?
divide.
You're going to divide. X is in the bottom, you divide. Let's see if we got one. All right, this one says, what is the angle of elevation? So I know that I'm going to be looking for my angle. Man is looking at the top of a billboard. He knows it's 50 feet tall. So the billboard is 50. He is 32 feet away from the base. What is the angle of elevation? Remember, they're going to put the little theta symbol in there. If you want to use an X, use an X. What does that matter? What is my equation going to be for that?
A tangent. 50 over.
Tangent of theta is 50 over 32. And if I'm looking for an angle, what am I going to do on the calculator?
The reverse.
The inverse, second sine, second, in this case, second tangent. Circles. Now, normally there's a bunch of stuff about circles on there. If you know the rules and stuff, it's real easy. In order to know the rules, we've got to know the definitions. The center, of course, is that midpoint of a circle that you decide how far you're going to go. Radius, how much is a radius?
Halfway.
It's halfway across, from the center to the circle. A chord touches the circle in two places. A diameter is a chord, but it goes through the center. A secant is a line that hits it twice, and a tangent is a line, ray, or segment that intersects it in exactly one point. Here are your diagrams of what it looks like. Radius is here. Diameter goes all the way through the center. Chord just hits the circle twice. Secant is a line that hits it twice, goes through it, and tangent hits it once. Give me a radius right here.
GF.
All right, what else?
GE. And GB.
G who?
GB.
And then GB. Yep. A secant.
AB.
AB.
All right, now you've got to be more specific than AB. You've got to say
Line.
line AB, because if I don't say line AB,
It'd be a cool.
then it turns into a chord, and that's not a secant. A tangent hits it one time.
CH.
It's got to be ray CH. And why does it have to be CH?
Because it only touches
The C is the one that has the point. So the C has to come first. Now chord, we've got a few different chords. Give me one.
AB, BD,
All right. Segment AB, BD, and BE. All of those are chords. Now of those chords, which one is also diameter?
EB.
B.
BE or EB, it doesn't matter. Remember, we've got common internal and external tangents. Why is it common internal?
Because
It's inside, it's in between them. External stays on the outside of both. How many common on the first one?
2,
I disagree.
4.
4. You got the 2 external and the 2 internal. How many here?
1. Oh, 2.
Here.
1.
Hey, finally, we got to our 1 right there. How many on number 5? There's none, because if I go through it, that doesn't count. Can't use it. because you can only touch the circle, each circle one time. So the only way I can touch this circle one time is to go through that other circle and it hits it twice. All right. If you have a line that is tangent to a circle, it has to make a right angle with a radius right there, where it hits that point of tangency. So this, if it hits right there, it's got to make a right angle. How would we check and see if these are tangent?
If it has a over this.
How do I know if it's got a right angle? How can I check to see if it's got a right angle? If I do Pythagorean theorem and it works, that means that's a right triangle and it's a right angle. If Pythagorean theorem doesn't work, then it would not be a right triangle, so then it's not tangent. What would I do on this one right here?
You find the radius.
I need to know that this part right here is how much?
5.
So then the whole thing is 13, and I would use 13, not 8. If you have two tangent lines from a point, or line segments, they're going to be the same. So what would I do with these right here?
You would do it if you was 5.
Or 7. Equals 31. Over here, I would say x squared equals 36. Just set them equal to each other and solve. All right. Central angle goes to the center, comes back out. An arc is part of a circle. Semicircle is half. Minor arcs are smaller than 180. Major arcs are between 180 and 360. Why can it not be 360?
Because it would be a full circle.
Then it's the whole circle again. Remember how we do minor arcs? Normally it's going to be 2 letters with the little arc symbol above it. If it's got 3 letters, which direction do I go?
Clockwise.
No.
Counterclockwise.
No.
You said what direction?
If it gives me 3 letters, how do I know which direction to go?
Just follow.
Follow the letters. B, D, C. I'm going to start at B. I'm going to go until I hit D. And then I'm going to finish when I hit C. I could take that same thing and say C, D, B and go the opposite direction and still be talking about the same thing. So it's not clockwise or counterclockwise for this. It's order of the letters. Now, if it gives me 3 letters, what is it normally talking about? A semicircle or a major. But it could do ZVY, like on this second one, and that's still a minor. If it's 2 letters, which direction do I go? But how do I know if it's BC, do I go from B to C or C to B?
Alphabetical.
Nope.
Just follow the letter.
Clockwise.
No, I just told you it's not clockwise, counterclockwise.
The shortest
Let
way.
me ask this. Let's do it this way. If I'm doing BC right here, do I go this way or that way?
Oh no, you go
The
right.
shortest way.
You go the shortest way. If it's 2 letters, you go the shortest way. All right. So if I'm doing this right here, the rule for a central angle and the arc is that they match. So BC on the outside here would have to be 40. How much would CD wind up being?
140.
Yeah.
Where's 140 coming from?
Because it makes a
180
line.
I know if it goes through the center, that makes a semicircle, which is 180. So 180 minus that 40. What about BCD?
BC. It's 180.
That's a semicircle. A semicircle's got to be 180. CDB.
360 subtract 40.
320.
I've got to go in this direction, so I need everything except that 40. 360 minus 40 leaves 320. DB?
DB.
DB.
180.
Doesn't matter which way you go, it's still going to be 180. All right, we did stuff like this. How do we fill in the missing parts?
Just add.
First thing I need to
One
do,
side should be 180. Both sides should be
Add the
180.
75.
So add the 75.
I can, well, I'm going to do this first. Those are vertical, so they got to match. Then I'm going to do what y'all are saying with the 180. I know that there's 180 down at the bottom, right? So I would add these two things up and get 130, the 75 and the 55. 180 minus 130 leaves 50 there. What about this one up here, the CAD angle? 180 minus the 55, you do 125. Once I have that, then I can start answering the questions based off of the angles inside. Remember, central angle matches the outside. How do I know if they're congruent? The arcs on something like this, are the angles the same on the inside? Those are vertical, it works. What about this one? Even though the angles are the same, what's wrong? The circles are not the same, so it wouldn't work.
Hey, how do you do that thing where like, okay, it was like that, and then like,
All right, what's the rule here? If the chords are the same on the inside, the arcs are the same on the outside. So if BC is 121, then DE is going to be 121. Same rule here. The arcs are the same on the outside, so then those are going to be the same on the inside. How would I find? All right. How would I do number 3 down here? It's asking me to find this little piece at the top right here.
It's equal to the
These are equal. The 80 and the 80 are equal.
So you can add all them up and then.
There you go. Add them up and subtract from 360. What would I do on this right here?
They're equal, so you.
So I would say 4x equals 80 minus x. Solve it. Plug it back in and start finding all the outside pieces. All right. Inscribed angles down here at the bottom. Inscribed goes to the circle and comes back. It does not go to the center. Remember, central angles match the outside. Inscribed angles are half of what's on the outside. So if it gives me the inside, how do I find the outside? Multiply by 2. The outside part's bigger. If it gives me the outside, divide by 2. This one messed people up last time. There's going to be 74, and there's going to be 30. Multiply by 2 to go out, divide by 2 to go in. But then how would I find that right there?
You add up.
No.
I've got a semicircle at the top. Do 180 minus 74.
That's what I was talking about.
So you got to look at what you got, figure it out from there. Remember on this, A and B are going to be the same because they make the same arc across, and then C and D are going to be the same. The ones on the same side are going to match. Here, if you see a semicircle, you know you've got a right angle. If you see a right angle, you've got a semicircle.
So what that mean? Like what question would you ask?
It would do this and say, what is angle B? When I see a semicircle, I know 180. Cut that in half, that's got to be a 9. All right, this one right here, I tried to get us to understand it, and for some reason we did not. The rule says the opposite ones are supplementary. What does supplementary mean?
180.
Add to be 180. So in this case, all right, we'll finish it up with this right here. On this one, it says a quadrilateral can only be inscribed if it's supplementary, if the opposite angles are supplementary. So A and B, or excuse me, B and D are supplementary because they're opposite. So they equal 180. And then C and E add to be 180. What did we do wrong when we were doing them before?
We was
We were trying to make a
Y'all would put them equal to each other. That's the common mistake that people make, is they put the opposite ones equal. It's not what the rule says. It says they got to be supplementary.
So it was like, never.
This video will show how to bisect an angle using a compass and a straight edge. So let's see. So we have a given angle A, and what we're going to do is place our compass point on point A, open up our compass arm, large enough so that it will be able to intersect both sides of angle A. Make an arc. And then what you're going to do is then label the two intersection points, B and C. Then take your compass, place the point on point B, and open up the arm of the compass over halfway between the two sides of your angle. Make an arc. And then using that same radius, put compass point on C, and go ahead and make another arc, which is congruent to the arc you had just made. The intersection of those two arcs will be a point on the angle bisector. So let's label that point D. Then taking your straight edge, place your straight edge such that you make a line that goes through points A and D. And there you have it.
This video will show you how to construct the perpendicular bisector of a segment. You can use this construction to construct a 90-degree angle, and it also locates the midpoint of a segment. So you want to start with a segment somewhere in the middle of your page. So you have some space above and below. Remember that perpendicular means it's going to cross at a 90-degree angle, and bisect means that it's going to cut it into two congruent parts. First step is to take and set your compass so that it is more than halfway across the segment. I'm going to set mine about this much. I'm going to make an arc above and below the line with my point stabbed into one endpoint. I'm going to move my point to the other endpoint, stab it in, and make intersecting arcs above and below the segment. Then I use my straight edge, connect those two intersections, and that's my perpendicular bisector.
All right, so you see, most of these things are real short and real quick. It's just going to ask you what would be the next step. So that's what I'm saying. Next week, you need to watch, and they'll say, what is the first step on doing a perpendicular bisector? It would be make the arcs at the top and the bottom. But I can't know that for you. You know what I'm saying? So you need to watch these again before we get to it.
This video shows how to draw an equilateral triangle inside a given circle using a ruler and a compass. First, set your compass to the length AB and draw a circle centered on A. Without adjusting the compass, draw another circle, this time with center B. We'll give names to these intersection points. Call this one C. And we'll call this one D. Now draw the circle centered A, again with radius AB. The distance between C and D is exactly the right length to be the edges of the equilateral triangle.
Tutorial is going to show you how to construct a square inscribed within a
Yeah.
circle. The first thing you're going to do is you're going to define the center of the circle. Next, using your compass, you're going to create a circle given a certain radius. Now, similar to the last video, we are going to divide our arc, the outside of the circle, into 4 equal sections. So to begin, I'm going to define the diameter of the circle. And I'm going to label it A. And I'll label this one C. Now, in order to find the other 2 points, I am going to find the perpendicular bisector of the diameter. So to do that, I'm going to stretch it a little more than halfway, create an arc, flip it, the other way, and create another arc. Now using a straight edge, you're going to connect the 2 points of intersection. I'm going to have to slide this over a little bit. Now make sure that your perpendicular bisector passes through the center of the circle. Now, what you have just created is you have divided your arc into 4 equal sections. So to create your square, you're going to take, I'll make mine a little thicker so you can see the color difference. The points of intersection, you're going to connect them. And that is going to create a square inscribed within a circle.
So why?
Hello, let's draw a regular hexagon inscribed in a given circumference. The first step, we are going to draw the vertical diameter which cuts the circumference at 2 points, A and D. So the next step, with our compass set to the length of the radius of the circle and centered on point A, we scribe an arc which cuts the circle at 2 points, as can be seen here in the video. Now with our compass centered on D, we repeat this process. And we cut the circle again at 2 points. As shown here. As can be seen, our 2 arcs pass through our center point 0. So now we have the 6 vertices of our regular hexagon inscribed in a circle. So finally, the last step is to join our vertices B to A, B to C, C to D, D to E, E to F. And finally, we close our hexagon, joining points A to F.
Wait, so you only use two angles?
Mm-hmm. Because you're finding that point right there, which is one of those I told you, centroid, circumcentric, one of those. And when you find that and you make the compass go to there, it's going to be the same all the way around. And I don't expect you to remember this stuff right now. What I'm saying is watch it Wednesday and try to remember it for Thursday. Because all they're going to do is ask, all right, if you're doing an inscribed, a circle inscribed inside of a triangle, what's your first step? Do an angle bisector. I mean, that's all it's going to be. You're not going to have to make one and remember all the steps. You just got to remember what's the next step. Most of the time, if I remember right, it's going to be what is the first step. I think there's one more.
To a circle. So one of the things that we've just discovered is that tangents to a circle are perpendicular to a radius at the point of tangency. So what does that mean? What that means is this. If we draw a radius, and for our purposes we're going to need to extend it because we're doing some construction. Where the radius touches the circle is what is called the point of tangency. That is the point at which our tangent line is going to touch our circle. And then what we can do is we can use our perpendicular bisector construction or our perpendicular construction, place the stylus on the point of tangency, and on each side on the radius, strike an arc. Then we can open our compass up a little bit more, and from each of our 2 points, strike an arc, and you can go above and below if you wish.
What is he making right there?
But because we have the point of tangency, we can do it just one side. I'll go on both sides though.
But what kind of bisector?
Inscribed.
No.
And if we draw the line to
Perpendicular.
those two intersections,
Makes a right angle, then it's gotta be
we
tangent.
will have
How does he know how far to open
a
it up?
tangent to our circle,
You open it up longer than halfway.
and by definition, a tangent is a line that intersects a circle exactly once. Then we can see that it intersects at the point of tangency.